This is section 11.6. We're going to talk some more about probability. If we know P of E, which is the probability of an event, we can determine the probability that the event will not occur, and we use this notation by using this formula. So we take 1, subtract the probability that it will occur. So let's say, for example, we have 2 red mittens and 3 green mittens. So altogether, we've got 5 mittens. So if I want to know the probability that we will get a red mitten, well, there's 2 red mittens, so the probability would be 2 out of 5. On the other hand, if we wanted the probability of not red mitten, we would take 1, subtract 2 out of 5. Sometimes it's easier to find the probability of something not occurring than it is to find the probability that it will. Yes, you will have to leave this as a fraction, but you will have to subtract. You do have to take 1, subtract 2/5. Now to do that, we're going to take 1 and change it to a fraction, which is 1 over 1. And we need a common denominator. So we've got 1, we've got 5. We need 5. 5 will be our least common denominator. So we have to multiply this fraction, top and bottom, by 5. So we've got 5 over 5, subtract 2 over 5. Remember, when you're subtracting fractions, you subtract the top. So 5 subtract 2 is 3 over 5. Yes, I know this is a fairly simplistic example, but I'm hoping to show you the process with a simple example that you can understand, rather than a complicated example right off the bat. Probability. 1 minus the probability that it will not occur. So this we're going backwards. So if we know that the probability of something not occurring, then to get the probability that it will occur, we take 1, subtract. You are dealt 1 card from a standard 52 card deck. Find the probability that you are not dealt a queen. Well, first we have to figure out the probability of being dealt a queen, and there are 4 queens in a 52 card deck. And if we simplify that, we get 1 over 13. So that's the probability that we will get a queen. The probability that we will not get a queen is 1, subtract. Now here's a hint. Whatever this number is, we're going to make top and bottom for the 1. So 13 over 13. You guys know if I take 13 and divide it by 13, I get back to the 1, right? So it doesn't matter what this number is, you put the same number on top as you do on the bottom. That will give you 1. Alright, so we've got 13 over 13, subtract 1 over 13, subtract the numerators, 12 over 13. Remember, I want a fraction, I do not want a decimal. Do not change this to a decimal. Scientific calculators will do fractions. Make sure you keep it a fraction. Mutually exclusive events. These are events that are impossible for them to occur at the same time. When we have OR with mutually exclusive events, we add the probabilities. So let's go back to the mittens. We've got 2 red, 3 green, and maybe 7 yellow. Let's make that yellow. Okay. So altogether we have 12 mittens. And the question is, what's the probability of getting red or green. Red or green. Well, you guys know to get red or green, we take the 2, we take the 3, and we get 5 out of 12. So we're adding the two probabilities. More mathematically, we would take 2 out of the 12 and add the 3 out of the 12. So this is the probability of red or the probability of green. We add them together and guess what? We get 5 out of 12. If one card is randomly selected, find the probability of selecting a king or means add when we're talking probability, a queen. So we've got 4 kings out of 52, and we've got 4 queens. If we add those together, because it says or, we get 8 out of 52. You do have to reduce it. When you reduce it, let's see, 4 goes into 8 twice, 4 goes into 52 13 times. So the probability of a king or a queen is 2 out of 13. We know these are mutually exclusive because it's not possible for a card to be both a king and a queen at the same time. So these would be mutually exclusive. To find the probability of or, we just add the two probabilities together. On the other hand, if they're not mutually exclusive, what that means is that it is possible for two events to occur at the same time. So when we do that, we have to change the formula. So we do add the probabilities, but we have to subtract off where they overlap. So if I were to draw a Venn diagram, we've got A over here, and we've got B over here, and we've got stuff in the middle. Well, we don't want to count that twice. If we count all of A, that's here, and if we count all of B, that's here, notice we counted the middle twice. So that's why we have to subtract off where they overlap. Okay. We've got a group of 25 baboons. 18 enjoy grooming their neighbors. 16 enjoy screeching wildly. 10 enjoy both. The both, remember, that goes in the middle. So if 18 enjoy grooming their neighbors, but 10 enjoy both, there's only 8 that just enjoy grooming. If we have 16 that screech, but 10 do both, that leaves 6 that only screech. Okay, so to find the probability, remember there's 25 baboons, so we would take the 8 out of the 25, the 10 out of the 25, and the 6 out of the 25. And notice I did not count that 10 twice. So you add those up. 16 plus 8 is 24 out of 25. Okay. Now, if you want to actually use the formula, you would take the probability of grooming, which is 18 out of 25, the probability of screeching, and subtract off the 10 that do both. Probability is 24 out of 25. Odds. I know in regular conversation we tend to use that word interchangeably with probability. Mathematically, it is not the same. For odds, we take what we want, that goes on top. That's the same as probability, but what goes on the bottom is different. For odds, what goes on the bottom is what we don't want. whereas probability, this would be the total. So let's go back to the mittens. 2 red, 3 green. So the odds for getting red, we want the red, so that's 2. We don't want the green, so that would be 3. Whereas this would be odds. On the other hand, if I'm asking probability of getting red, probability would be 2 out of the total, which is 5. Notice these two numbers are not the same. Odds, we have 2 out of 3. Probability, we've got 2 out of 5. Odds against, probability of not occurring over probability that it will. Single six-sided die. The odds in favor, so that's what we want, of rolling a 2. Well, how many ways can we roll a 2? We can roll a 2 one way. Then the question is, how many ways can we not roll a 2? Well, how many other numbers are there? There are 5. So the odds, 1 to 5. Let's suppose we know the odds and we have to figure out the probability. Well, remember odds, what we want, what we don't want. So what we want is 2. Okay? So the odds, we 2 ways for our horse to win. What we don't want is 5. We don't want, not want 5. But there's 2 ways to get it, and there's 5 ways to not get it. So altogether, total, we've got 7 ways. So this is what we want. This is the total probability. And the homework.